In this problem we have a 200 kilogram block on a 35-degree angle frictionless ramp with a thruster keeping it at rest on the ramp. So therefore everything would be in equilibrium, so we know that F net equals 0. So F net in the x direction equals 0, F net in the y direction equals 0. We also know that mg would equal the weight of the block, which is 200 kilograms, times the weight of gravity, which is 9.8 newtons. And we know that theta equals 35 degrees. So now we can do a free body diagram. This is our block. The normal force would be here, we'll call that Fn. Gravity would be straight down, call that mg. And the thruster force would be in this direction, and we'll call that Ft. And I'll choose my coordinate system like so. This is y, this is x, so we know that this would be 30 degrees. So we're trying to find f of t, which is in the x direction, so we need to find the x component of mg. So we know that mg in the x direction would equal the magnitude of mg times the cosine of 35 degrees, which is the angle. And we know that the sum of the forces in the x directions equals f of t minus mg in the x direction. And we know that all that equals 0. So to solve for f of t, we just have to add mg in the x direction to both sides. So we get Ft equals mg in the x direction. So f of t equals mg cosine 35 degrees, which equals 200 kilograms times 9.8 newtons over kilograms. Cosine 35 degrees, which is equal to 1605.5 newtons would be the exerts, what the thruster would have to exert on the box to keep it at rest on the plane. And we know it's newtons because the kilograms would cancel out.